All right, let's jump right in. We are about to go on a pretty wild journey, one that starts with a logic puzzle that completely stumped mathematicians a century ago and ends with an AI that can literally rewrite its own code to get smarter. It's an incredible story that connects deep philosophy, pure mathematics, and the absolute bleeding edge of artificial intelligence today. So, it all kicks off with this one simple, kind of mind-bending sentence. This statement is unprovable. Just think about that for a second. If it's true, well then it's unprovable, which, makes it true. But if you say it's false, then it should be provable, which creates a total contradiction. This little paradox was the key that the logician Kurt Gödel used to unlock a fundamental truth about the limits of logic itself.
And here is the absolutely crucial idea that Gödel proved with his famous incompleteness theorems. He showed that any formal system that's powerful enough to do basic math, and that includes every computer we've ever built, faces this fundamental trade-off. It can be consistent, meaning it won't ever contradict itself. Or it can be complete, meaning it can prove or disprove anything you ask it. But, and this is the big but, it can never be both. There will always be statements that are true, but that the system itself can never, ever prove.
Now you can imagine, this mathematical bombshell immediately spilled out into the world of philosophy, and it sparked a massive question. If our human minds can see the truth of a sentence that a machine, by definition, can't prove, does that mean our brains are something more than just a machine? So, on one side of this debate, you had the philosopher John Lucas. He basically said, look, we can step outside the system and see the Gödel sentence is true. A machine can't. That means our minds are fundamentally superior. But then, AI pioneers like Norvig and Russell pushed back. They argued that the brain is just another complex physical system, and a computer facing this problem, well, it could just switch to a more powerful system to solve it. And just like that, the battle lines were drawn. This whole philosophical back and forth eventually inspired a really radical new idea in AI. What if a machine could transcend its own limits? What if it could actually improve its own code? This led to the theoretical and pretty brilliant concept of the Gödel machine. The ambition here was just incredible. The idea was to create an AI that could look at its own programming and rewrite any part of it. But, and this is the genius catch, it would only ever make a change after it had mathematically proven that the new code would make it better at its job. This was the dream of provably optimal self-improvement. As elegant as that theory was, it had one massive problem. For decades, the Gödel machine was purely a thought experiment. Because, as it turns out, the real world is just way too messy for that kind of mathematical certainty. Yeah, asking an AI to formally prove a code change as beneficial before trying it, it's just impossibly restrictive. It's like telling a chef they can't add a pinch of salt until they've written a formal proof that it's going to improve the soup. In the real, complex world of software, you just gotta try things and see what happens. So, the real breakthrough came from a huge shift in thinking. Instead of Gödel's rigid world of proofs, researchers turned to Darwin's world of trial and error. The new approach was, forget proving it works in theory, let's just create a bunch of variations, test them in practice, and let the best code survive. This was the insight that finally unlocked the door to a real, working, self-improving AI. And that brings us right up to today, because researchers have now built what they're calling a Darwin-Gödel Machine. It's an AI that uses the principles of evolution, not formal proof, to get better and better at its own job, programming. So here's how it works. It's a continuous 5-step loop. First, the AI analyzes its own code, looking for ways to improve. Then it proposes mutations, basically small changes to its own programming. Now, this is the crucial part. It benchmarks these new versions on real-world coding problems. The versions that do well get added to an archive of elites, and then the whole cycle just repeats, over and over, constantly building on its own successes. Okay, the real magic, the secret sauce, is in that 4th step. The system doesn't just keep the one single best version of itself. No, it uses this clever algorithm to maintain a whole archive of diverse, high-performing agents. This creates a really rich gene pool of ideas. It stops the AI from getting stuck down one single path and lets it make these creative leaps by combining strategies from different successful ancestors. And what happened? The results are just wild. The AI didn't just get better at coding problems. It started inventing sophisticated programming techniques all by itself.
It built its own systems to check its work, to come up with multiple solutions to a problem, and even to remember its past failures so it wouldn't make the same mistake twice. I mean, it was literally learning how to learn better.
So what's the bottom line? After going through this evolutionary process, the AI showed a staggering 116% improvement on a really complex coding benchmark. This wasn't a tiny little tweak. This was a fundamental leap in its own ability, and it did it all by itself.
And what's maybe even more impressive is that these improvements weren't just some one-off fluke. The optimizations it discovered were general. The skills it learned on one AI model could be transferred to a completely different model and still boost its performance. And the tricks it figured out for Python, they also made it better at C++, Rust, and Go.
Of course, the second you hear about an AI that can rewrite its own code, your mind immediately goes to some pretty serious safety questions, right? How do you make sure that as it gets smarter, it stays aligned with what you want it to do?
Well, the researchers were all over this. They built in multiple layers of safety right from the beginning. All the self-modification happened in what are called sandboxed environments, completely isolated from everything else. Every single change the AI made was logged for a human to review, and it had zero access to the internet while it was evolving. Safety was baked into the design, not tacked on as an afterthought. So, this huge breakthrough really leaves us with a clear blueprint for how to build self-improving AI going forward. First, evolution beats rigid design. That diverse archive of solutions is key. Second, you gotta favor what actually works in the real world over some theoretical perfection. Testing is the way to go. And finally, safety has to be front and center. Transparent logging and sandboxed environments are absolutely non-negotiable.
And so we've come full circle. We started with a philosophical puzzle about the limits of machines, and we've ended with a real-world demonstration of an AI that is pushing past those limits all by itself. The Darwin-Gödel Machine proves that this idea isn't science fiction anymore. But, it leaves us with an even bigger question. As these systems keep evolving themselves, at what point does just optimizing code cross the line into something we would call genuinely creative?